Hi everyone. In today's video, I'll be talking about past exam question 26, exam 2019. And this question is about critical path analysis. You can get this question from our website as well. Study Ninja website. If you go to the relevant chapter, questions are sorted by chapter and by different types. So if you click on 2019, question number 26, this is the one we are talking about. So let's take this question out. So to solve this question, all the skills that you need are in the notes and resources that we have provided on our website. So I will take out a bit from the relevant section for this question. So this part you can find under, let's see, under critical paths. So if you go here, so this explains what is each of these boxes are doing within a network diagram. Let me take you through how we're going to use it. Well, I think that will be the easier way to understand. So we have this question. The question is asking you to draw a network diagram and then determine the minimum time for the project to be completed. So let's start doing that. So here what I've done as a first step, you make a structure of the diagram. You put the different nodes. So getting back to the question, for example, A was the initial activity and it takes 2 hours, a time of 2. So A is the starting point. There is nothing before A. That's why A is here. And there is a time of 2 next to it. Then B and C dependent on A and their time was 6 and 5 hours. So B and C, 6 and 5 hours. And then so on, you will complete the diagram. E dependent on C and D. So E dependent on C and D and took 4 hours. So that's why the diagram is like this and so on. So then the next thing, the first thing that you will do is you will do what is called a forward scan. Now what a forward scan is, you move forward from left to right and you complete what is called EST and EFT, earliest starting time and earliest finish time. This section of the box is for earliest start time and this section of the box is for earliest finish time. What is the earliest start time? Earliest start time, the earliest the activity can be started. So the earliest you can start is at time 0. You can't start before 0. So you put a 0 over here. And for earliest finish time, all you need to do is just add this number onto earliest starting time and you'll get earliest finish time. So 0 plus 2 is 2. Then the earliest finish time of A will be the earliest starting time for B and C because these two activities depend on A. You cannot start B before A is done. So earliest you can start B is when A is finished. So you take 2 from here and put 2 as the earliest starting times for activities B and C. The earliest finish time would again be similarly done as we did for A. 6 plus 2, 8. 5 plus 2, 7. Moving on to D. D cannot be started before B is finished. So the earliest start time for D is 8, which is the finishing time for B. Earliest finishing time. Then the earliest finishing time for D would be 8 plus 2, 10. Now, here's a bit of challenge. For E, you've got 2 times over here. One is a 7 and one is 10. So earliest E can start, E depends on both D and C. So E cannot be started until both of these are finished, which means that even if you finish C after 7 hours, it's not good enough for E because it still needs to depend on D to be finished, which the earliest it can finish is by 10 hours. So the earliest E can start is at 10 hours. So in these kind of situation, take the maximum of the two maximum of the 2 hours that are there. Same way you will go 10 plus 4, 14. 14 is the earliest finish time for E. earliest starting time for F would be 14. 14 plus 1, 15 would be the earliest finishing time for F. Now, part A, this is the answer to part A, because part A was asking you uh, determine the minimum time for the project to be completed. So the earliest the project can be completed is 15 hours. You cannot finish it before 15 hours. Now, coming to the second part of the question. Second part of the question is asking you determine the float of the non-critical activity. Well, to do that, let's complete the remaining bits of the diagram. I'm giving you a longer explanation just to help you understand how this whole thing works. There can be a shorter way to complete this, but just for your understanding. We'll do a backward scan to determine the latest starting time and latest finishing time. So latest starting time comes here and latest starting time comes here and latest finishing time comes here. So start off from the earliest finish time, which would be the latest finish time for activity F. Subtract the time it takes, which makes it 14. Take this 14 up, which would be the latest finishing time for E. Subtract 4, you get 10. Take the 10 here and here, you get 8 and 5. For B, you'll take the 8 from here, subtract 6, you get 2. Now in this situation, A, there are two activities that are going back to A. So in this kind of situation, you will take the minimum. So you take the 2 and you subtract 2 from here and you have a latest starting time of 0. Now, just to explain what is going on here, A cannot be the latest you can start A is 0, because if you start at any time later than 0, the whole project is going to be delayed because everything depends on A. That's why the latest starting time is 0. And the latest finishing time also is same as earliest finishing time, because it starts the latest starting time and the earliest starting time is 0. So it takes 2 hours. So the earliest you can finish is 2 hours, and the latest you can finish this is also 2 hours. Otherwise, the whole project will be jeopardized. But something like this is interesting. For example, C. What C is telling you is that you can start C as early as 2 hours, or you can start at as late as 5 hours. What does that mean? This means that if you start at time 5, at 5 hours, 5 plus 5, 10, it will be completed at time 10 hours. 10 is the time that is needed to, latest time needed to start E. Because if you start it at any point later than that, the whole project will be delayed. So this kind of situation where C has got some sort of a capacity to be started at a later time, and the earliest time is different than the latest start time. These are called the non-critical activities. So float is the difference between earliest start time and the latest start time. So difference between these two we write over here. So 0 and so on. We complete all of these. The activities that has a float value other than 0, which is 3 in this case, is a non-critical activity, which in this case is C. So the answer to the question would be 3. Float time for non-critical activity is 3 hours, with C being that non-critical activity. Everything else is critical. By critical, I mean that if you delay any of these activities, A, B, D, E, or F, by even 1 hour, the whole project is not going to finish in 15 hours. It will finish later than that. Hope this makes sense. Thank you.